In this video, we will talk about how to determine if an equation is linear. So we say that an equation is linear if it can be written in this form, y equals mx plus b. So let's work through a few examples. Let's say we have the equation 3x plus 4y is equal to 12. Is this a linear equation? So the idea here is we want to see if we can get this equation to be in the form of y equals mx plus b. Or in other words, we want to solve for y. We want to get y all by itself and see if the right-hand side of the equation looks like mx plus b. So to get y all by itself, we can start by subtracting a 3x from both sides. So we'll get 4y is equal to, let's say, negative 3x plus 12. And then to get y by itself, we just need to divide every element by 4. So if we divide by 4, we'll divide this term by 4 and this term by 4. So on this left-hand side, these 4's cancel out, and we're left with y is equal to, over here we have negative 3/4 x plus 12 divided by 4, that's 3. So here is our final equation. So is this a linear equation? It looks like yes, because it matches the form y equals mx plus b, where m is negative 3/4 and b is 3. So we'll go ahead and write linear for this equation. All right, let's try another example. Let's say we have x squared plus y is equal to 5. Is this a linear equation? So once again, we want to get y all by itself and see if it matches this form of y equals mx plus b. So to get y by itself, we can subtract an x squared from each side. On this left-hand side, these x squareds go away, and we're left with y is equal to, we'll say negative x squared plus 5. So is this a linear equation? Well, notice that the exponent on the x is greater than 1. So that's a dead giveaway that it's not a linear equation, because this exponent must be equal to 1 in order for the equation to be linear. And we would actually say that this is a quadratic equation. So we will say not linear. All right, let's try another example. Let's say we have x times y is equal to 15. Is this a linear equation? Well, once again, we want to solve for y, so we want to get y all by itself. So to do that, we can divide each side by x. So the x's will cancel out on this side, and we'll be left with y is equal to 15 over x. So this is not a linear equation because x is not allowed to be on the denominator of a fraction. Or if we really wanted to rewrite it, we could say y is equal to 15 x to the negative 1. And notice that this exponent is not equal to 1. So another dead giveaway that this is not a linear equation. So we'll say not linear. All right, let's check out another example. Let's say we have y is equal to the square root of 2 times x plus 3. Is this a linear equation? Well, when you see this square root of 2, it might throw you off, and your immediate reaction might be, no, this must not be linear. But actually, the square root of 2 is just a number. So if you punch it in a calculator, it's just something like 1.41421, and on and on and on. So it's just some number multiplied by x plus 3. So this does actually match the format of y equals mx plus b, where the square root of 2 is m and 3 is our b. So for this one, we would say this is a linear equation. All right, let's try another one. Let's say we have 4 is equal to 8x divided by y. Is this a linear equation? Well, first we want to solve for y, so we want to get y all by itself. So the way that we can do that is we can multiply both sides by y. So over here, these y's cancel out. On the left-hand side, we're left with 4 times y is equal to 8 multiplied by x. To solve for y, we can divide both sides by 4. So over here, the 4's go away, and we're left with y is equal to 8x over 4. So notice that 8 divided by 4 is just 2. So we can rewrite this as 2x. So is this a linear equation? Yes, because if we imagine that the b out here is just 0, then this perfectly matches y equals mx plus b. So we would say this is a linear equation. All right, let's try one more example. Let's say we have y over x is equal to x plus 2. Is this a linear equation? Well, we need to solve for y. So we can do that by multiplying every item by x. So we multiply this one by x, multiply this one by x, and multiply this one by x. So when we do that on the left-hand side, these x's cancel out. We're left with y is equal to x times x, that's x squared, plus 2 times x, that's plus 2x. So is this a linear equation? Well, no, because we see that there's an exponent that is greater than 1 attached to this x. And remember, for a linear equation, we can only have x to the first power. So we would say this equation is not linear.